All right.
Let's
I'm
see.
here. I'm monitoring it. So call me if there's any issues. Everybody knows we have tech issues, so you don't have to go into it. Enjoy your.
All right.
Enjoy.
Are you seeing anything yet?
You're good. You're live.
I believe I should be live now. Finally.
I'm getting you live now.
All right. Great. All right, folks, this is me again from the Sierra Foothills, Jeff Curtis, and very happy to see you. The reason for the delay, I'm afraid my computer did something unexpected, and my wife rescued me, so we are now working off of her computer. What I'm going to be talking about tonight is a continuation, really, of this series of brief informal chats on consciousness and current events, current thoughts, news items that have come up. And last time we spent a little while talking about artificial intelligence and some of the ideas surrounding that topic. I went a little bit into is consciousness happening from a bottom-up or a top-down perspective? Is consciousness something innate to the universe that settles into a sufficiently complex set of networks? It's an idea behind how one might construct it. I'm going to step back from those details right now, and I just want to spend a little while catching you up with some of the current trends and events in the whole area of consciousness, and catch up a little bit on my own information stream, just because it's sort of fun to do that. And I'm going to start to just give you an idea here of showing you a little bit of the vast activity taking place in this area and how it has exploded. This is just fun for me. I started going to conferences on consciousness back in, first one was 1999 that I attended. It was really great. It was at the Flagstaff University in Arizona. It was called Quantum Mind, which is pretty cool. And that was related to the series of conferences that they have in Tucson, Arizona. And so since then, well, before then and since then, I've been trying to pay attention to the literature. And one of the ways in which I do that now is with a particularly wonderful weekly news magazine that I get. It's called New Scientist. And so what I'm going to do now is just kind of hold up to the camera here and show you a little bit of the activity that's taking place in this area, because it's just so phenomenal, and it just goes and goes. So here is the most recent issue of New Scientist, and as you can see, feature article is on consciousness. It's 10 biggest questions about the greatest mystery in the universe, and it's a wonderful multi-page spread. I can't really recommend this magazine any more highly. It's just a wonderful way to stay up with science. They have short articles, long articles, always well written and very good. In this one, they go over a number of important topics that are confounding and entertaining the scientific community. Some of the questions being addressed, for example, in this particular issue: how many states of consciousness do humans have? Of course, long ago it was thought, well, we have two. It's sort of like on, off, asleep, awake. We're now realizing that it's much more complicated, partly because our instrumentation has gotten so good and we can discern different patterns of activity, states of excitation in the brain, and these at least correlate, if not necessarily cause, states of mind. And this becomes one of the important aspects of the science. So they go through a number of these. They identify altered states of consciousness. They identify various gradations of comatose awareness, because it turns out that even people who are behaving comatose, if you examine their brains carefully with sufficient encephalography, you'll discover some of them are conscious in there. and they are suffering a phenomenon called locked-in syndrome. In the last 7 or 8 years, people have learned actually how to communicate with individuals who are in a fully aware but body turned off, locked-in syndrome. There have now been multiple individuals who, by answering yes-no questions and responding to a monitoring assistant with their brain waves, the patterns in their head, have written books by slowly, letter by letter, dictating sentences, then paragraphs, then chapters, and entire books. You can read a book written by someone who was comatose when they wrote it, as phenomenal as that is. So that's an incredibly important compassionate use example of modern technology and encephalography and fMRI, that we can actually do that for people who are in that kind of a dreadful circumstance. In this particular article, they go on through a number of questions like, can physics explain consciousness? And that's a particular interest of mine, as you've picked up in my last couple of lectures. It connects with an interest in quantum mechanics and the nature of wave function collapse. One of the theoretical ideas they bring out here is the now quite famous idea of Penrose and Hameroff, that consciousness has something to do with states of quantum superposition in the microtubule structures that occur in neuronal axon structure. We have about 87 billion neurons in our head, and each of those can have between 100 to 1,000 connections. Complicated situation up there. And in each of these neurons, in the axonal structure that I drew for you in one of the last discussions, there are semi-rigid compilations of tubulin dimers that can exist in a state of quantum superposition. And this is very aggressively promoted as a possible explanation of consciousness. It's not particularly one that I personally buy into, but it's very much worth knowing about, and there are people in the community who are testing it, studying it, coming up with reasons why it might or might not be true. And very interesting question. This would be question number 5 in this particular exposition. When did consciousness evolve? This is a difficult thing to pin down, but the answer might surprise you. There are a number of biologists now who are pretty sure that the first signs of what you might argue to be the brain architecture necessary for conscious awareness have evolved 3 separate times in humans and in birds and in mollusks, arguably also in insects. The first such event happening somewhere between 350 and perhaps as long as 500 million years ago with a very ancient common ancestor. So at least to the extent that we understand the brain architecture, which can support conscious awareness, this is a big if. But a number of people take this hypothesis quite seriously, and I'm going to be looping back to this idea in a few minutes with sort of a closing exposition I wanted to get to. Just to keep going a little bit with this magazine thing so you'll see some of the diversity. This is from about a year ago, but it was a really good one. Is the universe conscious? Sorry, this is hard to do. This one also rests a lot on the underlying physics and the various ideas for and against are tied to ideas evolving in modern physics. In one of the earlier lectures in this series, I mentioned the fact that there's a debate between materialism, or a purely physical-based idea of what consciousness is, and then differing shades of dualism, and including something called quantum interactive dualism. That all comes together in a quite fascinating and complex way in this particular article. I'm not going to be going deep into that one. I'm just doing a brief survey. I wanted to stop on these next two, and then I think I'll probably cool it with the magazines because I have too many. This is really fun. This is a very recent issue. Are trees sentient? Remember the Ents in the Lord of the Rings series? It was one of the really cool parts of that whole fantasy world. The giant walking conscious trees. Remember the role of the mother tree in the Avatar movie. Turns out that James Cameron was thinking, to some extent, about the scientific work of this woman. Her name is Suzanne Simard. I think this is probably a person worth knowing about. She has now conducted beautiful scientific studies showing the extent to which the trees, in conjunction with the microrhizome mycelial structure of the surrounding fungus in the soil, are communicating chemically in something approximating real time. It's a little slower. The connections between trees that feed forward and backward through the soil and connect forests and connect communities of trees are mostly depending on chemical messengers that diffuse along through the small root structures, which then interface to the mycelial structures of the fungi. It turns out that trees are communicating a rich structure of information. They alert each other when there's something bad going on. The trees are capable of recognizing their own offspring. So a mother tree will communicate differently to distant trees of her own genetic lineage than to closer trees of the same species but not direct genetic link. So there are families of trees intermixed and communicating information in a different way to each other. So a forest is beginning to look like it might be a slow but nonetheless potentially conscious entity. That's really something worth stopping to think about. Her data is exploding. James Cameron is now got her on board. She's actually consulting with him right now because they're making another installment in the Avatar series of movies. So I think you can expect to see this especially amazing aspect of the science of consciousness being probed and modeled even more deeply in his next movie. I think it bears mentioning that this whole notion connects in a really beautiful way with an idea that was popularized some years ago by a biologist and ecologist named James Lovelock in the Gaia hypothesis. It's called the hypothesis. I think it's probably more than just a hypothesis. Hypothesis is science speak for guess. I think probably the Gaia hypothesis has got a little bit more going for it than a guess at this point, and certainly as it is now vastly supported by the notion that forests have at least a network structure of chemical communications very much resembling the same kind of network structure as we have in the neuronal, much faster acting structure of neural architecture in our heads. So that's really quite a thing. Suzanne Simard, somebody worth watching. One other one, just fun to see the diversity. This also is a recent issue. What animals are really thinking? So this is a whole multi-page spread devoted to the topic of how do we assess, how do we measure, how do we understand consciousness in animals. This article focuses mostly on vertebrates, and they have something to say about invertebrates. But even even with insects, there's fascinating evidence that they are more conscious than we might think. A particular interest of mine scientifically, and one that I have a kind of a project in my head for how I would do, is to explore the topic of to what extent are protozoans conscious and capable of communication over distance. I think I'll leave that whole topic for another discussion. But the idea of consciousness in animals is particularly appealing. Lots of people will focus in on that and have a great interest in it. And there's even evidence for psi phenomena. So where you have consciousness, you've got psychology, and of course you've got parapsychology, or what we might call psi phenomena, psi effects. I believe that many of you will have heard the name Rupert Sheldrake. He's a particularly frontier, out-of-box thinking guy, a biologist, and he's done beautiful work. He very fertile mind, and one of his areas of endeavor has to do with something called morphogenetic fields. And the presence of the past, and the way in which the universe sort of records and holds information that then becomes available to conscious entities separated in space and time. It's controversial. There's evidence for and against, but something that he dwells on and is a slightly separate topic is the phenomenon of psi in animals. And he's the fellow who has a great website devoted to at-home psi experiments that you can do. It turns out one of the most reproducible evidences of psi effects in animals is the one called the, she has a name for it, it describes the phenomenon of your pet knowing when you've decided to return home from a journey across town. And they've now quite proven, this is not a hypothesis anymore, this is just now a fact if you open your mind and read his research, and it's been replicated. If you're halfway across town, you've been doing errands, your pet will perk up and behave differently at the moment when you get in your car and decide to start driving home. It doesn't have anything to do with them hearing your car. It doesn't have anything to do with time of day or external cues. Those are easy to control for. And so what they do is they'll put a video camera, these are time-synced cameras, on the person out doing their thing around town, and then time-synced to what their pet is doing at home. And a very substantial fraction of dogs and a similar, not quite as big, fraction of cats will go into a state of hyper-alertness and go to the door or the window and obviously be in a state of anticipation and excitation at that time when their human begins the trek home. Stop to think about that. You know, some of you out there, pet owners, might have noticed this. This was one of those things that got noticed by just normal people seeing correlations. Another similar such correlation that Sheldrake has investigated is the one where you look at the phone right before somebody you care about and are connected to calls you. That's the phone premonition effect. So yeah, psi in animals. It's actually active research, and I've come to believe it. Some of you folks out there that have been to my house in San Francisco when I lived there, you might have met my cat named Ralph. I had a cat named Ralph who totally had this. He knew when I was heading home, independent of the time of the day, and my wife was there to observe, and there was so many times when Ralph would go into that state when I finally decided to come home, and we could correlate it, we could timestamp it, me and her working together. So Ralph was complicated enough to do psi. So I have more of these. I could keep rapping along about that, but I don't want to because our time is short. I wanted to go into a related idea on the nature of consciousness as it expresses itself in animals. Now, you can still find people who will argue that animals aren't conscious. I won't. I'm, it's hard not to slap them. Frankly, they do show up at the conferences in Tucson. There you can be the hardcore materialists who just know it all, and they just know consciousness is a thing that the brain constructs, and we don't quite know how yet, but we're going to figure it out. And by the way, only humans got it. That idea is dwindling. There are fewer and fewer people in that camp. And there are more and more diverse definitions of and measures of consciousness, which include not only the animal kingdom and emerging in the plant kingdom, as I just explained, but even simpler, complex states of matter. Turns out that one of the theories of consciousness is called integrated information theory. It's developed by a particularly active researcher named Julio Tononi. And his idea is that whenever you have a sufficiently complex structure of matter, that you can have what we, as scientifically we call emergent phenomena. When emergent phenomena become possible, there will be some degree of measurement, some degree of information integration taking place. And in very simple structures that can actually be numerically estimated and worked with. His hypothesis, this idea has not yet been proven, but it's a contender. It's one to watch as far as the competition in theories of consciousness rolls forward. So back to insects. Okay, that's this one particular stop on the way. We can have humans, animals, invertebrates, octopus, insects. I forgot to mention fish. There's a very recent thing that came up is particularly nice YouTube there's a fellow named Anton Petrov. That's Petrov, Anton Petrov. If you go to YouTube and you type in Anton Petrov smart fish, you'll be led to a video about a recent discovery in a family of fishes called Mormyrides. It's a form of fish that exists in African freshwater bodies, and they're related to electric eels. It turns out there's many aquatic organisms that have exquisitely sensitive electric field, both detection and generation apparatus in their head, and they use electric fields to stun prey. They can use electric field detection to detect prey, kind of like echolocation, but often what they're looking for is subtle disturbances in the electric field in the water if there's a prey animal nearby, or particularly a prey animal that is bleeding, because that changes the electrochemistry and it sets up an electrochemical gradient in the water that they can sense as a voltage. Well, these fish have evolved their electrical apparatus in a different direction. There's a little patch of stuff down near the base of their tail that is their electrical sending and receiving unit. Well, turns out, we finally got around to listening closely to what's going on. It's looking very much like those fish are talking with electrical impulses. They have conversations where there's a speaker and the other fish stop and listen. And then the speaker pauses, and after a measurable period of time, one of the other fish begins talking. And you can trace these pulses going around in a group of fish, and the patterns are just like the patterns in human speech, and also has been identified in birds. So birds carry on conversations with their bird calls. Now, we have not been able to discern what you would really call a language or a syntax. It seems simpler than that with what's going on in the birds. But there's a clear pattern of speak, pause, listen, another individual speaks. So it's certainly a sending and receiving modality that has the fundamental pattern that could be containing speech. Well, these fish are doing it. And a particularly interesting aspect of these fish, a second technical failure, my printer decided not to cooperate. They're kind of cool looking little fish. They have a droopy snout, and the colloquial name for them is elephant fish, and they can be anywhere from a few inches to a little over a meter in length. That's a big fish. So they've got this kind of funny little droopy elephant trunk in the front of their face. One of the things we've learned by studying intelligence, let's say, in the animal kingdom is that there's a pretty strong correlation between the ratio of brain size or brain mass to body weight. And if you make a plot where you would put on the y-axis of this plot, you're going to put this ratio, brain mass divided by body mass, and measure, or excuse me, that's on the x-axis. And then on the y-axis, we would have some measure of intelligence, complexity of behavior, let's say. What you'll discover is that the organisms we think of as being intelligent, let's say us, dolphins, killer whales, these are the ones who come in at the top of this scale, have a certain body to brain ratio. These fish are right there, right in there with us. So of the organisms in the animal kingdom, these fish that exist together in communal societies in freshwater African environments have not only the requisite patterns of activity in their electrical sending and receiving, they're occupying, surprise, this was not realized until recently, they're occupying the same rung of the ladder as us, primates, and the cetaceans. So stay tuned on that, the elephant fish story. Is there another intelligent species on the planet that has just gone unnoticed by us up till now? Maybe so. And then what I wanted to close on tonight is a sort of a departure of sorts, but an amusing one. I'm going to show you a book, just a second here. Animals and Psychedelics. Author Giorgio Samorini. This is a fascinating, brief little book. It's great. It's got a wonderful table of contents. If you just look at the titles of some of this, I want to get down to and explain a little bit mushroom-loving reindeer, and then Lazarus flies, a new hypothesis. So this guy does a quite good job developing in his book the thesis that consciousness is by nature exploratory, and the extent to which consciousness arises in an organism, it's going to explore the boundaries of what that consciousness is. And what he amasses here is case after case after case of animals and even insects intentionally and deliberately putting themselves at great risk and getting stoned out of their minds. On alcohol, there's elephants love alcohol. There's birds will gravitate to fermented berries. There are animal alcoholics, and you can make alcoholics out of mice in the lab. The chemistry is very similar as to what happens to humans. Okay, that one's maybe a little bit less interesting, but more interesting and sort of captivating of attention has to do with animals that seek out altered states of existence, altered states of consciousness, more along the lines of what comes if you eat the fly agaric mushroom. So the fly agaric mushroom is it's not the same as the psilocybin mushroom. It's the beautiful mushroom that has like a red cap on it with little white dots. It's sort of, you've seen pictures of it a million times. You would know all about it. It has been popular and used by humans forever, and heavily documented in Europe. That people were cultivating and seeking out this mushroom for its mind-expanding capabilities, as long as we have records, and in primitive societies as well. Well, turns out animals like them, so caribou will seek out those mushrooms and eat them and really enjoy it. Now, stop and think about this for a minute. Those caribou are not well equipped for self-defense or fight or flight while they are tripping on mushrooms. Why are they doing that? Something is driving them. There is some innate impulse having to do with, as this guy would argue, consciousness exploring the boundaries of its cage, consciousness looking for all the various forms of that thing, consciousness, that their nervous system will support. If they have to eat some weird mushroom, they'll do it. Okay, so let me close back a little bit to the punchline story of this book, because it's really kind of cute. That mushroom, the fly agaric, its actual botanical name is Muscaria amanita. So it exists in the amanita family of mushrooms, which is toxic and dangerous. You don't eat amanita mushrooms unless you really know what you're doing as a mushroom hunter. The fly agaric is the trivial name given to the Amanita muscarica, because for the longest time people thought it was a way to get rid of flies. You'd take a couple caps of the fly agaric mushroom, this beautiful, lovely looking red mushroom, cut them, you masticate them a little bit, put them in water, put that on the windowsill, and not too long later, if you have a substantial fly problem in your home or outside, this dish where you have the water, it will have a bunch of flies laying there, dead flies, quote unquote dead flies, laying there in the mushroom juice. And then you can pick that plate up and wash them down the sink or throw it away or whatever you want. So it's considered a great way to get rid of flies. Well, something this guy documented, with work that he was tipped off on from other people, it's a fascinating story to read. Turns out, the majority of those flies weren't dead. If you watch closer what's going on in a plate full of dead flies in the liquid surrounding the Amanita muscarica, they're not dead. They lay there for anywhere between 30 minutes and 15 hours, and then they get up and fly away. People thought that they were dying, but a few of them do die. But what is happening actually is they reach a steady state where the flies are coming in, they're laying there, they're tripping their little brains out for some period of time, then they wake up and leave, only to be replaced by other flies. Hence it's a steady state situation that looks like an endpoint of a bunch of dead flies. It's not. Those flies are landing there, hanging out, having some kind of experience, and then leaving. And this has now been reproduced. Now, I can't say I've combed the literature for all the many people who I'm sure have done their best to debunk his hypothesis. Okay, maybe I'll let you guys do that. If somebody wants to debunk or reaffirm Giorgio Samorini's hypothesis and research work on the shroomed out flies, please do. I'd love to hear back from you. But I find it a charming story. I always like it when we discover that we knew less than we thought. And then secondarily, it's particularly fascinating to think that consciousness, whatever it is, and as I've explained before, we don't have a really good definition, but whatever it is, it seems to want to explore the boundaries of its cage, and it'll do things like develop the science of yoga, develop mind-altering drugs, or just by trial and error, if you're a fly, figure out what kind of mushroom juice to go lay in order to have an interesting day. So that'll cover it for now. I'm sorry about the slow start and technical difficulties, but it's a pleasure being with you all, and I hope you're having a wonderful summer. So, Jeff, out. Have a great day. Bye.